Hey everyone, welcome back. I asked Claude if my login had any bugs. It said no.
Then I ran it in a real browser, and nobody could actually log in.
That gap between looks correct and actually works is what this whole video is about.
Quick disclaimer, this is not Claude versus Kane CLI. It's not that Kane is better or an alternative. That's not the point. This video is about one thing, testing. How you test while you're coding and how you test after you're coding. I want to create an aha moment in the layer most people skip.
All right, let's start with the login.
So this is the app, and I built the whole thing with Claude Code. It's a small commerce-style site. There's a landing page with pricing, a login, a cart, and a full checkout flow. Free and pro plans, a buy pro button, the whole thing. A real app with real flows. Exactly the kind of thing you actually need to test. First, I'm going to tie one hand behind Claude's back on purpose. I tell it, do not use Kane CLI this session until I say so. Watch what happens. I ask it to confirm a user can actually sign in. And notice, Claude flags the problem itself. It says, confirming a real sign-in means driving a real browser. Navigate, fill the email, get the code, submit. That's exactly what Kane CLI does. Since I told it not to, it offers me a choice. Run it live with Kane CLI, or keep Kane off and just reason about the code. I pick the second option, stay static. I want you to see the ceiling of code reading on its own. So Claude reads everything, the Supabase client, the sign-in call, the verify call, the session handling, and it builds this table. Every step gets a green check. The wiring is correct. And here's the honest part, right up front. Claude says it plainly. This cannot confirm an actual sign-in. It can only tell you the wiring looks right. Read that line again with me. It says the code is wired correctly, and in the same breath it says static analysis cannot confirm a real sign-in. That's the whole video in one screen. Looks correct is not the same as works. Now I ask it straight. So there's no bug, right? And it says, correct. No functional bug in the login logic, as far as static review can see. Then it draws a hard line. It literally lists the things it cannot know without running it. Whether the backend actually authenticates, whether an email really goes out, whether a real code verifies. So on paper, clean bill of health, no bug. Now I lift the restriction, run the exact same flow with Kane CLI, agent mode, headless. Claude loads the Kane skill, spins up the dev server, checks the login page is actually live, and hands the flow to Kane CLI in plain English. Go to the login page, fill the email, click send code, confirm the 6-digit step appears. And there it is, failed. The login screen renders fine, the form submits, and then the sign-in call dies, failed to fetch. Kane CLI does a real DNS lookup and finds the truth. The Supabase project this app points at does not exist anymore. The backend is gone. A real user cannot sign in. Full stop. This is the aha moment. Static review said no bug, and static review was right about the code. The wiring is perfect. But Kane CLI ran it in a real browser and found that nobody can actually log in because the backend the app talks to is dead. That is a failure you cannot read in the source. It only shows up at runtime. Looks correct, then verified it does not work. And I love how Claude reconciles it. Both things are true. The code has no bug, and a user still cannot sign in. Reading the code got you the first half. Kane CLI got you the half that actually matters to a user. And this is the other piece. Every Kane run gives you this, a replay, a step trace, a link you can drop into a pull request or a bug report. Not, trust me, I tested it. Actual proof anyone on your team can open. Second run. Before we even test the checkout, let's build the tests for it. And I don't want to handwrite them from memory because I'll miss things and I'll invent fields that don't exist. So I ask Claude to generate test cases for the Buy Pro checkout, covering the real fields and edge cases. Then Claude loads the Kane skill and hands those grounded details to Kane's generate command, and Kane CLI writes the test cases for me, in plain English, matched to the real UI. You can watch it work through, generating. Here's why this matters. On its own, an agent will happily write you a test that asserts on a button that doesn't exist because it's guessing from patterns. This flips it. Claude reads the real page, Kane CLI generates test cases that fit that page, and you get tests grounded in reality instead of imagination. That's the difference between a test that looks plausible and a test that actually maps to your app.
Now let's actually verify that checkout flow. This time I let Claude use its own browser tool first, the one built into the agent. I want to be fair. Claude can drive a browser on its own here, so let's see how far that gets us, and then where Kane CLI adds something. Claude walks the flow. Home, pricing, buy pro, checkout. The navigation works. The checkout page shows the right plan and the right price, $19. Then it gets to the real question. Are the inputs in the pay button actually interactive? So it tries to type a card number and click pay. And the verdict? It does not work as a real purchase. The card fields are disabled, nothing types in. The pay button is dead, clicking does nothing. There is no payment backend at all. The page even admits it in the markup. It's a mock. You can see the price, you cannot actually buy. Good catch. So here Claude's own browser did find it. Now I run the identical flow through Kane CLI, and two things happen that matter. One, it agrees. It gets stuck at the exact same wall because there is no next step to take. So now I have two independent methods saying the same thing. That is confidence. Two, look at this captured values table. Plan, billing, the total, the button label, the final URL. Kane didn't just pass or fail. It pulled the real values off the live page and handed them back to me. That's the kind of thing you assert on in a real test suite.
Kane CLI saves you from the loop of continuous prompts and speeds up your verification. It turns the check into something durable, a structured pass or fail, real values pulled from the running page, and a shareable replay. Claude found the mock. Kane CLI proved it, captured it, and gave me a link to show for it.
Now a tiny one, the kind of thing you'd never write a test for. Does the back to site link on the checkout page actually work? Again, I start Kane off, just Claude reading the repo. Claude opens the file, finds the link, and tells me exactly what it is, a Next.js link pointing to the home route. The home route exists, so on paper, it's wired up correctly. And this is the line I want you to hear. Claude says it itself. It says, if you want, I can spin up the browser and click through it to confirm it visually. Just say the word and I'll run Kane CLI. That's the honesty I keep coming back to. Claude knows the difference between the link is coded correctly and I clicked it and it worked. It read the static code, gave me the reasonable answer, and then told me the only way to actually confirm it is to drive a real browser, which is Kane's job. So I say, now check it with Kane CLI. It loads the skill and actually clicks the thing in a real browser. Now I don't have the code looks right, I have I clicked it and it works. That's the upgrade, even for something this small.
Before this next part, one quick thing to explain, because it's a Kane CLI feature a lot of people haven't seen. These .md files, a test.md. Think of it as your test written in plain English, saved in a file. It just says what the flow is and what to check. Log in, create a project called Smoke, confirm it shows up in the sidebar. That's it. No selectors, no code, no framework. You get one of these two ways. Either from the generate step I showed you earlier, where Kane writes the cases for you, or by recording a run once. And when Kane saves it, it also saves a recording right next to it in that output folder. So the test lives in your repo like any other file. The point of saving it, anytime your app changes, you just replay it, one command. That's your regression test. That's what we're about to do. So here's the saved test, 12 steps, already recorded. Claude replays it with one command. All green. Passes clean. Good. This is the baseline.
Now, let's say a teammate changes that button label from create to add project. They ship it, they forget the test, and that's exactly where things quietly break.
Now I run the same test again. And here's the nice part. I'm just putting the same Kane CLI run prompt back in. I don't have to re-explain anything. And watch what Claude leans on here. Kane CLI. In agent mode, Kane CLI writes out an ND.json file on every run. That's basically a line-by-line record of everything that happened. Every step, every action, what it saw on the page. So when Claude runs it again, it reads that previous ND.json file first.
That's how it knows what happened last time and understands the run properly. Claude isn't guessing from the code anymore. It's reading Kane CLI's actual record of the browser. And see, it failed this time. Because this was a test drift. The app changed, the test didn't. Someone renamed the submit button from create to add project. The recorded test is still looking for a button called create. That button doesn't exist anymore, so the click fails.
Kane finds it, Claude explains it. Then Claude makes the call that matters. Is this test drift or a real bug? The UI intentionally changed. The app isn't broken, so this is drift. It updates the test to the new label, re-records, and runs it again. Green. That's the heal. The app moves, the test breaks at runtime, Kane shows you exactly where, and Claude updates the test instead of you hand-editing a selector. And it even tells you the recordings are safe to commit, so your CI stays in sync with the change. Quick, simple explanation first, because this word gets thrown around a lot. A regression is when something that used to work stops working. You had a feature, it was fine. Then you changed some code somewhere else, and without meaning to, you broke it. That's a regression. The feature went backwards. Regression testing is just this. You keep a test around for the things that already work, and every time you change your code, you rerun that test to make sure you didn't accidentally break something that was fine yesterday. That's the whole idea. Did my new change quietly break an old thing? The save test you just watched, the login and create project one, that's a regression test. Now let me show you it doing its actual job. First, I change the price right here in the checkout code. $19 becomes $29. That's the regression. Now here's the test that guards it. 2 steps. Step 1 opens the site, clicks Buy Pro, and lands on checkout. Step 2 checks the total is $19, the known good price. And that's the whole idea. The correct price lives in the test. The actual price lives in the code. If someone changes the code, the two stop matching, so it fails right here. Code says 29, the test expects 19. And the moment it fails, it stops. It skips the rest of the flow because the regression's already caught. That's the guard doing its job. Last flow, the full end-to-end pass. Same setup. Kane off to start. I tell it, the op's running locally, test the whole build end-to-end. So Claude, with its own tools, gets you a long way. Build passes, flow works, one styling regression found. Now I run the same end-to-end through Kane CLI. And this is where the check becomes a real test. I gave Kane CLI the objective, and Kane ran it step by step. It opened the local URL in a real browser, checked each thing, and verified the whole build at 3 times the speed. Look at this assertions table. Not it seemed fine. Each claim is spelled out and checked. The pricing card shows 19. The checkout plan is Pro. The total is $19. The pay button says the right ding. Every assertion green. And you finish with this, a named, saved, shareable end-to-end run. Verify and purchase Pro plan. Anyone can open it and watch the exact path step by step. So the pattern held all the way through. Claude is genuinely strong. It reads your code, it can drive a browser, it catches real problems. But Kane CLI is what turns a one-time check into a repeatable, assertable, shareable test. Explicit assertions, captured values, a replay link. The difference between, I looked at it and it seemed okay, and here's the proof it works.